Welcome! Today we're going to explore an important feature in modern motor protection systems, dry run protection. You might have heard of this term before, especially in industries that rely on pumps, compressors, or other motor-driven equipment. But what exactly does it mean? Let's break it down. In simple terms, dry running refers to a situation where a motor is running without doing the work it was designed for, typically because there's no fluid or load to drive. In applications like water pumps, for instance, this could mean the motor is running without any water flowing through the system. While it may sound harmless, running a motor in a dry condition can be extremely damaging. Without the fluid or load to absorb heat or provide lubrication, the motor can overheat, leading to severe damage to the bearings, windings, and seals. In the worst-case scenario, it could result in a complete motor failure and costly downtime. That's where dry run protection comes in. This feature is designed to automatically detect when a motor is running without load or fluid and then take corrective action to prevent damage. Depending on the system, dry run protection might stop the motor, send an alert, or activate a safety mechanism. Dry run protection typically works by using sensors that monitor key parameters of the motor system, such as temperature, current, or pressure. For example, in a pump, a flow sensor detects whether the fluid is flowing as expected. If the flow drops below a certain threshold, indicating a dry run, the system will trigger a protective response. One common approach is to monitor the motor's current consumption. Motors generally draw more current when under load. If the motor is running without load, the current draw will be much lower. The dry run protection system detects this anomaly and immediately shuts down the motor or triggers an alarm. Another method involves monitoring pressure or flow sensors in pump systems. If no fluid is flowing, or if pressure drops to an unsafe level, the system can activate a shutdown process to prevent motor damage. There are different ways dry run protection can be implemented, depending on the application and the type of motor. Some systems use direct monitoring, while others rely on indirect measurements like vibration or temperature rise. Regardless of the method, the core goal is the same: protect the motor from damage due to dry running. If dry run protection wasn't in place, the consequences can be dire. The motor can overheat quickly, causing insulation breakdown and electrical failure. Bearings can become damaged from lack of lubrication, and seals may wear prematurely. Over time, this leads to reduced efficiency, costly repairs, or even total motor failure. Thankfully, with dry run protection, all these risks can be avoided, ensuring the longevity and reliability of motors. The system allows the motor to continue running smoothly even under variable conditions and minimizes the risk of expensive repairs or unplanned downtime. To sum it up, the key benefits of dry run protection include preventing motor overheating and damage, ensuring longer motor lifespan and reliability, reducing maintenance costs, improving operational safety. In many industrial applications, dry run protection is not just a luxury, it's a necessity. Whether it's a pump, compressor, or any other motor-driven equipment. This simple but effective protection mechanism helps keep things running smoothly and safely. Thanks for tuning in. Now, you have a better understanding of what dry run protection is and why it's essential for motor reliability. Stay safe and keep those motors running efficiently. Dry run protection, safety, efficiency, reliability. Make sure to press like and subscribe the channel.